Hello there, Mr. Monroe speaking. I just want to do a very quick video to talk to you about histograms. Well, sometimes they're called frequency diagrams. Now these ones are equal width, and that is the highest difficulty that you will encounter on the GCSE foundation paper. On the higher paper you can have ones with unequal widths, which are a bit more interesting, but that's obviously not going to be in this video, and obviously they are well above grade 5. So here I have some group data. Now notice the symbols, the inequality symbols, right? So time taken, i.e. t. So here, the time taken, this could be like for doing a jog or on the phone or something. I haven't filled this completely in, but you get the idea. So time taken here is between 0 and 5, but very importantly, t can be 0, but it can't be 5. So for example, you know, the data could have been 0, 0, 1, 2.3, 4.9 and so on, and you would have ultimately had 13 of these bits of data because the frequency is 13. Now sometimes doing these questions you might actually be given the raw data and you have to tally it up and put the frequency in, but to save us time I've popped that in there. Now just remember, 5 appears here, 5 appears here. This is obviously grouped frequency. 5 on its own would be in this category, not this category. This is technically less than 5. So what makes a histogram different from a bar chart? Well, bar charts essentially should have gaps between the bars, and the reason for it is a bar chart is used to show you qualitative data or discrete data. So it can be the number of people at a party, or your favorite food, that kind of stuff. Now a histogram does continuous data. It does a range. So notice here I have 2.3, 4.9. I can have decimals in this, and it expresses a range of data. So I'm going to set up a little histogram. Now I've just about managed to find some square paper. Now if you do not have grid square paper, you can do this on lined paper at home, but of course accuracy is always going to be a problem. So you need to measure the widths very carefully. Now this goes up from 0 to 20 in terms of time. Now that is going to be going along the bottom, because this is going to be my time taken. Now I am starting at 0, so I'll put a 0 here, but sometimes you start at like 130. If I started at something like 130, what you'd probably do, you could have 0 here. Now you don't really want to have to go 0, 10, 20, 30, 40, 50 and so on to get to 130. That'd be silly. You can do a zigzag. This essentially breaks the line, and then I could do 130, 140 and so on. It saves space, but it's very important that everything is equally spaced out, otherwise it won't work. So anyway, back to this. So I've got my time taken. I'm going to use 4 squares wide, and then I'm literally just using these groups up here to space it out. So I've got 0 to 5, 5 to 10, the next one's going to be 15, and the next one is going to be 20. Now I am going to need to extend this slightly. That's what I get for trying to be clever. Now next, the frequency goes here. Now if this was a normal histogram with unequal widths, this would be frequency density, because the widths are different. The height is not necessarily frequency, it's the density. But again, that's a normal histogram. If you want to check that out, just Google a histogram video. There's plenty of those around. Now I don't necessarily want to go up to 18. I could 18 squares. The thing is, you need to be realistic. That's going to take a bit of time. I'm actually going to be sensible. Let's say I want to go up to 20. Now again, I could do 1, 2, 3, 4, 5, but I'm actually going to go up in 2s because it just makes life a little easier. So 0, 2, 4, 6, 8, 10, 12, 14, 16, 18 and 20. Now obviously before I drew this line I should have counted, because technically I went a little bit higher than I need to, which, you know, that's not the end of the world, but it doesn't look as nice. So for 0 to 5, I've got a frequency of 13. Now 13 is going to be in between, and that's perfectly fine. It's in between 10 and 14. Now that bar needs to go up from 5 like so. Now what's important is that my next bar, which is essentially time is equal to or greater than 5 or less than 10, that's 18. These bars can touch, okay, because these literally are next to each other. They are touching, essentially. So the bars should touch as well, and this is what makes it different to a bar chart, because bars technically shouldn't touch. This is a type of bar chart, of course, it's just not the one you're used to. So 18 is here, so I'm going to just draw that. I really wish I had a see-through ruler. Okay. Again, accuracy is important. Obviously, I've got square paper here. You can do this without square paper. I suggest you use the lines of your page to measure your vertical axis. And for horizontal, I would actually just measure 2 centimeters, 2 centimeters, 2 centimeters, because accuracy is key. In the real exam, of course, you would be given some kind of grid in which to draw. Next, my next one is 10. So just coming across here. And again, this is actually fairly straightforward. There's nothing too much to write home about on this skill. You just need to understand about the difference with gaps and bars. So you all know about bar charts, and this is just an evolution of bar charts. The last one, 15 and 20, and goes to 4. And here we go. Now, there we go. Now normally I would give this a title as well. Now when I made the question up, I didn't actually give it any context, but normally you would have a context and you could include that like this. Now you can actually get questions on this regarding, so say that sometimes you actually get one of these drawn and they'll say, okay, how many people took at least 10 minutes? And again, so that would be 10 minutes going up, so you'd measure this one at 10, this one at 4, and add those together. So it'd be at least 14 people were, or 14 people were at least took 10 minutes. And again, I should probably put minutes there, but again, I didn't specify that up top. So again, that is just a very quick introduction to drawing a histogram. Remember, it's basically a bar chart, and the features need to be there. We need to label our axes. The biggest feature, of course, is that the bars are touching, and that must only occur for continuous data. So remember, this won't happen for favorite colors or discrete data, like, the number of cars in a car park. Okay, this is for anything that could be measured, so lots of decimals with these ones. Okay, thank you very much, and I hope you found it useful.